Hello Bobcats. In this video we will be discussing acid nomenclature. Now we know an acid is an acid because acids begin with a hydrogen. So if your formula has a hydrogen in the up front, then you know it's an acid. So it's another decision step when you're looking at a formula to decide how to name it. So remember, if it has a metal to begin with, it's going to be ionic. So it's a metal to a nonmetal, that's ionic. Then if you have a nonmetal to nonmetal, then you know it's going to be covalent. And if your formula begins with a hydrogen, then you know it's going to be an acid. Now there are three rules to naming acids. And so let's look at rule number one. And rule number one is that if the anion of the acid ends in IDE, and remember, endings with IDE are usually the monatomic ion, anion, but there's a couple of polyatomic anions. So usually it's going to be monatomic. If it ends in "ide", the acid name is hydro root, so that's the root word of the anion, ic. So you have hydroic acids. So if your anion ends in "ide", then you're going to write hydro whatever anionic acids or hydroic acids. Some examples: if I have HCl, we know it's an acid because it has H in the front, then that is a chloride ion. Remember, it's monoatomic, so it's going to end in "ide", and chloride goes to hydroic, so that's going to be hydrochloric acid. That's hydroic, hydrochloric acid. Let's do a couple more to make sure we understand. Let's say we have HBr. Again, it's acid because it has a hydrogen to start. This is a monoatomic ion, that's bromide, and ide ion, anions go to hydroic acid, so that's hydrobromic acid, hydroic. Now these were monatomic ions, but there's every once in a while you'll have a polyatomic ion that ends in "ide". So like this one, it's cyanide. That's polyatomic because it has two different elements. Cyanide, so this would be hydrocyanic acid. Again, hydroic with the root base, cyan for cyanide, acid, so hydrocyanic acid. So if it ends in "ide", it goes to a hydroic acid. The next one we'll look at is if, it's rule number two, if the anion of an acid ends in 8. Okay, so if it ends in 8, we know it's polyatomic. Ends in 8, the acid name is root word of the anion, ic, acid. So 8 goes to ic, 8 to ic acids. So let's look at a couple of those. So let's say I have HNO3. We know it's an acid because it has the hydrogen. This is nitrate, so 8 goes to ic, so that'll be nitric acid. Let's look at another one. So H2SO4, it's got hydrogen in front, that's sulfate, so this is sulfuric acid. Again, 8 to ic, sulfate to ic, 8 to ic acids. A couple more, H3PO4, that's a hydrogen up front, so it's an acid. That's phosphate, so this is phosphoric acid, 8 to ic. Now hopefully you've recognized a pattern here. Remember nitrate, and let me write that over here, so nitrate ions, NO3, 1 minus, that's a nitrate. So 8 goes to ic. That 1 minus, you have to have the same number of hydrogens to match the negative charge, because hydrogens are positive. So over here we had SO4, 2 minus, so that's sulfate. And so I needed 2 hydrogens to match the 2 minus, and so that's sulfuric acid, and so forth. Let's look at one more. Let's say I have HClO3. Now that is chlorate. So this is chloric acid, 8 to ic. Now I wanted to show this because a lot of students will get confused between chloric acid being HClO3 and hydrochloric acid being HCl. They get these two mixed up. Now the last rule is number 3. That would be if the anion of an acid ends in ite, the acid name is root word of the anion ending in us. So ite goes to us, acid. Of course you have to write acid. And so let's look at some examples. If I have HNO2, remember that goes from nitrate to nitrite, that's nitrite. So ite to us, so that'd be nitrous acid. Or let's say we have H2SO3. Remember we went from sulfate with SO4 to sulfite with SO3. That ends in ite, so this would be sulfurous acid. Let's look at one more. What if we have HClO2? So the ClO3 is chlorate. This would be chlorite. So ends in ite, so that would be chlorous acid. Okay, so again, remember we're looking at the anion. So if this anion, which NO2 1 minus is nitrite, then it's going to be nitrous acid. Ite to us. Or SO3 2 minus is sulfite. Remember, sulfite goes ite to us, so that's sulfurous acid. So that's the rule for the 3 rules for naming acids. Now we actually have gone from the formula to the name of the acid. Sorry, from the formula to the name. But let's look how you would go from the name to the formula. What process would you be thinking? So let's look at going from name to formula. So let's say I give you a name like carbonic acid. Now, the first thing I look at is I notice that it's ic, and remember ic has the 8 anion, and so that would be carbonate. So remember the carbonate anion, C carbonate anion is CO3 2 minus, and so I would need 2 hydrogens, so my acid name would be or my acid formula for carbonic acid would be H2CO3. So remember, ic to 8. Or another example would be, let's say I have fluorous acid. So I look at the us, and remember us goes to ite, so this would be fluorite, anion, fluorite, and fluorite is FO2 1 minus, and so my acid formula would be, since there's 1 minus, it would be HFO2, and so us goes to ite. Remember, ite ions. A last example for this we'll look at, what if I have hydroselenic acid? Okay, so now again I'm looking at hydro-ic, so that means I'm looking at an ide anion. And so selenide, selen is the root for selenium, and so that would be a selenide ion, selenide anion, which is Se2 minus, a monoatomic. And so remember, hydro-ic goes to ide. Selenide, which is monoatomic, is a 2 minus. So this would be H2Se. So that's how we go about doing those. Now, one little bit of information that is important to understand is that acids only exist in water. So acids must be dissolved in water. If they are not in water, then they're not an acid. So acids must be dissolved in water. And to do that, we use a symbol. AQ means dissolved in water. Aqueous, aqua. So that's dissolved in water. So a lot of times, especially in practice, my practice sheets, you'll see an acid with this written by it. So, and the reason it's important is, let's take an example. So I have HCl, and if I put this, that means it's a gas, and then I have HCl, and that would be AQ, aqueous. Okay, this is not an acid. This would be written as hydrogen chloride gas. Okay, but now that it's aqueous, this would be written as hydrochloric acid. Okay, now I'm not going to be that particular right now, knowing the difference between the two. Whether if it's a gas, it's not the you wouldn't name it an acid, and if it's aqueous, you would. But when we start writing chemical formulas, or I mean chemical reactions, and we have to state this, give the state of matter like gas, solid, liquid, or aqueous. Acids, if you wanted to indicate it as an acid, you'd have to put aqueous. So I wanted to make sure everybody understood that also, because sometimes you'll notice in my practice problems you'll see the AQ next to it, and that's just because I'm making sure that you understand it's an acid in that case. So like up here, if this wasn't written with an AQ, that would be hydrogen selenide gas. But right now we're just worried about naming acids, so we'll call it hydroselenic acid without using the AQ. I just wanted to clarify that. And that is it for acid nomenclature. Thank you.